Good morning, children. Today I'll be starting with the first class of class 12 and I'll be teaching you matrix. Now, matrix is a chapter which was also included in your class 10's ISC exam. So the basic concepts and the fundamental operations are already known to you. All that you had learnt about matrix in class 10 is included in your class 12's syllabus. Let me define to you once more the identity matrix. Now, what is an identity matrix? An identity matrix is a square matrix, all of whose principal diagonal elements are equal to 1 and off-diagonal elements are equal to 0. Now, this is an identity matrix of order 2 denoted by I2. Now, this is one diagonal and this is also another diagonal. This we call the principal diagonal. So in an identity matrix, the elements of the principal diagonal are equals to 1 and rest all elements are equal to 0. Here I have an identity matrix of order 3 rows, 3 columns. This is the principal diagonal, all of which are equal to 1. All elements are equal to 1 and rest all the off diagonal elements are equals to 0. So this is an identity matrix of order 3. The next definition is of transpose of a matrix. Now, transpose of this matrix A, denoted by A prime or A superscript T, will be obtained if I write down the rows as the columns. Look here, the first row is written as the first column, the second row written as the second column, the third row written as the third column. This is how we obtain the transpose of a matrix. So transpose of a matrix is obtained when the rows and the columns are interchanged, or vice versa when the columns and the rows are interchanged. We write down the columns as the rows. So here I have the matrix B, which has 2 rows and 3 columns. So it is of order 2 cross 3. Its transpose, denoted by B superscript T, will be given by 2, 3, 4. These are the elements of the first row. I have written them as the elements of the first column. Now the elements of the second row, 5, 6, 7, I am writing them in columns. So this is my B transposed. I have obtained it by interchanging the rows and the columns. Now order of B transposed will be equal to 3 cross 2, as there are 3 rows and there are 2 columns. Now we have a few properties of transpose of a matrix. The first property is A transposed, whole transposed is equal to A. If we transpose a matrix and again transpose it, we will get back the original matrix. The second property, A plus B whole transposed is equal to A transposed plus B transposed. And the third property is AB whole transposed is equal to B transposed into A transposed. So these are the 3 properties of transpose of a matrix. Now let me define to you a new matrix, which is a symmetric matrix. This is a new definition for you all. Symmetric matrix. Now what is a symmetric matrix? A symmetric matrix is also a square matrix where the element of the ith row jth column is equal to the element of the jth row ith column. Let me give an example. This matrix A is equal to 2, 3, 5. Elements of the first row will be the same as the elements of the first column. 0, 1. So the second row is now 3, 0, 1. The second column will also be 3, 0, 1, 8. So this is a symmetric matrix. A symmetric matrix is a square matrix and it is obtained if the element of the ith row jth column is equal to the element of the jth row ith column. Look here, this is A1, 2, element of the first row second column should be equal to the element of the second row first column and both are equal to 3. A1, 3 should be equal to element of the first row third column should be equal to the element of the third row first column and both are equal to 5. and A23 element of the second row third column should be equal to the element of the third row second column, and both are equal to 1. As these conditions hold, I can say that A is a symmetric matrix. Thus A is symmetric. So in general, when we write down a symmetric matrix, we write down the rows as the columns. Or we can say the most important definition of a symmetric matrix is that a matrix is symmetric when A is equal to A transposed. This is the condition for a symmetric matrix. The next definition is of a skew symmetric matrix. Now a skew symmetric matrix is also a square matrix. Moreover, all principal diagonal elements are equal to 0. All principal diagonal elements are 0. And Aij is equal to minus Aji. So let me give you the example. B, all principal diagonal elements should be 0. It should be a square matrix, and Aij should be equal to minus Aji. So this is a skew symmetric matrix, because I have here all elements of the principal diagonal equals to 0. The Aij is equal to A12 is equal to minus A21. A13 is equal to minus A31. A23 is equal to minus A32. So this is a skew symmetric matrix. Also, the condition in order to check whether a matrix is a skew symmetric matrix is B is equal to minus B transposed. If this condition holds, then we can say that a matrix is skew symmetric. B is equal to minus B transposed. Now, for any matrix A, for any A plus A transposed is always symmetric. So, if you are given a matrix A and you want to get a symmetric matrix, you add A to A transposed, you will get a symmetric matrix. And for any B, B minus B transposed is always skew symmetric.